All right, there we go. Okay, so just as that video finished talking about when we're talking about encoding and the elaboration process, is the better we can connect information, the better we use our spatial memory instead of our cognitive memory, the more easier it is to learn in a concept or an idea. And I think I expressed in the class a week or so ago that when we look at, for example, people who are seen to be very naturally good at mathematics, as an example, and they just seem to, it comes easy to them and all that. So what we find is very similar to the memory experts' brain scans. The memory experts use that parietal lobe. You remember we talked about the parietal lobe is about spatial information. It's about spatial memory and navigating within space and time. Well, like these memory experts, we find that people who are really good in math use that area of their brain instead of their frontal lobe. So they don't go through, for example, the order of operations and you know which you should do first, multiplication, division, additions, and those kinds of things. No, what they do is they actually see the numbers in their mind floating around, as it was explained to me, and they just start to combine with each other. And based on, you know, what they see, the answer comes to them as they imagine interacting with these spatial numbers and space. So it's again just an important point to be made. Okay, so when we go from the encoding process, what the elaboration memory system suggests is that we then need to work with that information. So I'm going to go through kind of three different type of memory systems. This first one was created in 1968. And then the thing that will change in this one is we'll go through what's called the short-term memory, and then we'll look at what's called the working memory. But I want to go through this respectfully from what we've researched historically. So the way to think about the memory system is kind of think about 1968 is when we started really looking at computer and computer systems. And when we think about a computer system, we have these three components. If we look at, for example, what your keyboard does, what your camera does, what your microphone does, this is analogous to what we call sensory memory. It is basically what you're putting into, for example, your keyboard, and then it's getting transferred to your short-term memory. The analogous thing with short-term memory is computers have something called RAM, random access memory. This is the amount of memory that you can process information at once. Okay, and you know when we first started with short-term memory, the RAM was very limited, and so it was proposed that our working memory and our short-term memory have a very limited capacity, and we'll look at that as we move forward. So think about short-term memory as RAM. It's the memory that is used to run your programs. It's what happens when you push on your keyboard and then it appears on your text message or whatever it may be. And then if you want to think about it, the hard memory, the hard drive of a computer is what we would call the long-term memory. So once we hit, for example, save on a Word document or something like that, then it gets stored into that hard drive, where then when it's needed again, it can be retrieved. So our memory systems are really based upon the computer systems that we developed. And if we want to look at it from a philosophical perspective, a lot of philosophers believe we created the computer system out of what we know as our human systems of processing information. So we did the sensory memory with thinking about our senses in the body. Short-term memory is when we're working with information, and then long-term memory is when we're trying to store it somewhere. Okay. So this is the basic model. You have a sensory input. I think, hold on just a second. I want to look at something. Yeah, okay. We have a sensory memory. This is where information first comes in. And then in the original model, when we attend to that information, it goes into our short-term memory. So when we start working with information in the word processor, this is what it goes into, and we start working with it. In the original model, it was believed that we only remember things when we rehearse it, and when we rehearse it over and over and over. So, for example, when I was in elementary school and then into junior high and stuff like that, they would give us lists of words to memorize. And the idea is you just rehearse those words over and over and over, over and over and over, over and over and over, until you came to the point where you then could remember them. So when rehearsal then goes into storage, and then when we need that information again, we retrieve it from storage. Now, this is going to be a big change in our next model, because as we've just talked about with the TED video and everything else, it's more about when we're looking at memory, making connections with information in long-term memory. And if you want to think about it this way, when, for example, you're doing something in Word, you have a certain connection with it. It has to have that abbreviation of .docx. And the only thing that the MS Word is going to recognize from long-term memory is anything that has the .doc or .docx. And that's kind of the idea, is making some type of connection with something in long-term memory to where it then can be retrieved at a later time back into our short-term memory system. Okay. So let's talk about sensory memory and what we know about it from research. Is that one of the things about sensory memory is it is a very rich and detailed information held in the original sensory memory form. But it has a very, very, very brief duration. We're talking fractions of a second, okay? We know about the sensory memory system because of research done on what's called echoic memory or auditory memory, and iconic memory or visual memory. And in these situations, what we do is we present somebody with a unique sound for fractions of a second. And then we do some type of task where either they raise their hand or they say, I just heard this sound, or I just saw this image. Okay. And that kind of gave us, but you ask them, for example, 1 second later, do they remember hearing that sound? And they'll say no. Or do they remember seeing that visual image? And they'll say no. So this is the idea that it decays very quickly, and we only retain the things that we pay attention to. And this kind of makes sense from the system, because at one moment we have thousands of sensory information coming in at us. We have Our skin cells are always, our skin receptors are always going off because of the touch of our clothes, the wind in the room, the temperature in the room. We have all kinds of visual information, and our environment is actually pretty noisy. And so if we just had a sensory memory system and not an attention system, we would all be kind of almost, if you want to think about this, severely autistic, where the world would become very overwhelming. And when we get to autism near the end of the semester, that is one of the main theories about people with severe autism, is they're not able to get rid of or control sensory memories. They're really feeling all the sensations at once, and they don't have the filters other individuals do. So what do? They go into behaviors they can control. They go into, they don't like being hugged or kissed, because that's just another big sensory experience that they then have to experience. But we'll get into that when we get into autism. But again, if we didn't have filters, our world would look pretty chaotic. Okay. Then when we talk about short-term memory, as I did mention, it is limited in capacities, and there are some updates that we need to do this. So this is when we attend. And remember, we talked about attention. And when we attend to something, it goes into our working or short-term memory, where we start to process it and use it in some way. If we don't continue to use information, it leaves in about 30 seconds. It has about a 30-second duration. So if I were to give you a list of a couple words, and then I told you not to think about those words, and I went on with maybe a lecture or something else, but if I stopped at 10 seconds, you most likely would still remember those words. 15 seconds, 20 seconds, 25 seconds. But if I waited beyond 30 seconds and said, hey, what were those two words that I told you not to think about a while back, because you didn't work with it, more than likely you wouldn't remember that information. So it does have a limited duration. And if you want to think about RAM memory, once you stop working with that information, it kind of goes away. You go to your MacBook and says, oh, we need to turn this off, or the like. Okay. It also has a limited capacity, just like our random access memory in our phones and in our computers. For us, and this actually has to be updated in 2012, we actually found that our capacity for memory is 4 to about 8. I should just put this line here, 8. If this 7 plus 2, it used to be, when they did the original research, we used to remember anywhere between about 5 to, let's see, 7 plus 2 is 9, but our capacity actually has been reduced based on research. So our memory capacity is between 4 to 8 chunks of information. Okay, which means that once we get beyond our certain limit, and it's really dependent on the person, I believe when I've taken a short-term memory test, I think mine was like 3 or 4. So I can handle 3 or 4 chunks of information at a time, and that's of course my capacity. And on next Monday, we will do a short-term memory test. It's a really simple one. It's about just remembering number digits. You won't have to really, let us know what your number is. But this is a very good tool you can use for a study aid. Okay, so how to use this as a study aid once you know your capacity, and we'll test that next Monday. Let's say you come up with a number and it's low, it's 3, that's okay. Well, when you study, what you should do is chunk information in 3s. Okay, so if you're memorizing, for example, a bullet list, memorize the first 3 bullets, memorize them well, and then go on to the second 3 bullets. Memorize them well, and then go on to the next. Don't try to memorize like a list of 12 bullets all at once, because you don't have that capacity within that short-term memory system. When you're reading a textbook, chunk things into paragraphs. So if your memory capacity is 3, read 3 paragraphs, make sure you understand them, go on to the next 3 paragraphs. And chunk the information into that capacity or that ability. Now, if you're kind of like me and you're a slow reader, just remember that you can put information in there, but it's going to have a limited capacity of 30 seconds. So if you have, let's say you have a short-term memory capacity of 8, but you tend to be a slow reader. So we have a limited duration and a limited, but you have a really good capacity within your short-term memory. Well, what you may need to do if you're a slower reader like I am, you may need to reduce this number in the amount of information you study at once, because you got to remember you have a limited duration to work with information. So, if you're a slow reader, like if I had a number of 8, which would be amazing to me, then I would probably, because of my reading ability, need to reduce the amount of information that I do to probably down to 4. Okay.
Yeah.
So kind of keep that in mind.
And this one. Oh. Yeah.
Okay. So this is the first things that we learned about short-term memory, is the duration and the capacity. And so keep those things in mind when you're learning. And like I said, on Monday, we'll do a little short-term memory task so that you can kind of see what your number is, so you know how to work with information as you move forward. Okay. So how can you improve your short-term memory? I just mentioned the idea of chunking information together. So a chunk would be, for example, a paragraph. A chunk might be a bulleted point piece of information, and the like. And beyond school, if you chunk things into units, so when you do your grocery list, chunking information into for example, dairy, vegetables, fruit, meats, and keeping them into separate categories can help if you're trying just to remember a grocery list just from memory. Okay. And then in the short-term memory system, and this is not the best system to use for this, but rehearsal, and that's conscious repetition of information, can prolong its duration. But remember, this isn't the best way to get that information to go to your long-term memory system, but it may help in a short-term period of time when you're just trying to, for example, remember how much change you need to get from your car to pay for something that's in the convenience store that you didn't have enough money for. Is repeating that in your mind over and over can help in those kind of situations. But the limitations of the short-term memory model is that it doesn't really hold up on getting information into the long-term memory system. Okay. In order to really look at what this is, I know what it is. Here, hold on just a second. There we go. So what we have had to do with the working memory system is really give it some upgrades, kind of like, again, what we do with random access memory in our phones and our computers. We have to think about it in a more complex way, okay? And so what has been developed to kind of add on to this short-term memory system is something we call working memory. It's also called an active memory system. And it really has three kind of components. And again, I'm going to go to the analogy now to use the analogy of our brain, okay, is the two main systems that have been investigated with the active memory system or the working memory system is the phonological loop, which is information of sound, okay, and sound systems, and how we work with sound in this memory system. And something called visual working memory, or it's also called a visual spatial sketch pad. And this is really doing with visual information, okay? So this, if you want to think about this, this is our temporal lobe, right, in the brain. This is our occipital lobe at the back of the brain. And then we have our central executive. This is a person who's working with all the visual and auditory, and we should add all of the other sensory systems onto this. But again, these are the ones that have been investigated the most. And the central executive uses all this information to make sense of our world and make sense of what's going on. And it's also going to draw from long-term memory, all of these things to give us our experience that we're experiencing right now, okay? So this is kind of, if we want to look at it visually, is that we have the input sensory systems. This again, the reason it's called the visual spatial working memory is it takes in time and space, so the temporal lobe and the occipital lobe. And it allows us then to look in the room and look at information and understand where it is in space and time and what it is visually, okay? And that's why it's called visual spatial working memory. The phonological loop is that auditory system. It's the one that is largely based on rehearsal. And it's called the phonological loop because you really keep information in the phonological loop by repeating that information over and over and over, okay? If you think about, if you think about something that you're really working with right now, you're probably repeating it over and over and over, even though you may be having a different experience with it, okay? Probably a system, something that we're all familiar with when it deals with this phonological loop that is kind of I don't know if you want to call it an abnormality of the system, but it's something that we all common, is when you get a song stuck in your head, okay? This is because what's happened is that beat or that music is getting stuck in this phonological loop, okay? Reason it's stuck there is because it's something that your central executive is saying it likes, that it wants, it's something that you're working with constantly because maybe it is synced with the brain waves in your head or something else. And so those things get stuck, okay? And just another tidbit, the thing that we have found to get rid of songs that are stuck in your head is to listen to a music genre that is a different tempo and whatnot that is opposite to what is stuck in your head. So if you have for example, a heavy metal song stuck in your head, listen to a country music song, okay? The one music that really doesn't work that can get it out of your head is classical music. if you're a classical music listener and you end up with SpongeBob SquarePants song in your head, listening to classical music will actually make it worse, not better. So that's the only one that this really doesn't apply to, but it makes sense because every music genre is based on those simple sounds of classical music and that were created over the thousands of years of human existence. But that's just a kind of an extreme example of things that can get stuck in that phonological loop. But that's really what this is about, okay? So the central executive, if you notice these arrows, it's getting information to and from these systems. But look at this is probably one of the big ones, is the central executive also is using long-term memories to make sense of things. That's why we have these double two-ended arrows. And so when we're working with our visual sketch pad and maybe we see something unfamiliar, the central executive is then accessing information from long-term memory to try and interpret that visual information. And same thing from the phonological loop. Maybe there's a sound we've never heard or words we're not familiar with. The central executive will go into long-term memory and try and access something that is similar to that to try and make sense of all that information. So this is kind of the updated model. If you want to make the analogy with a computer, your visual spatial sketch pad is kind of like your word processing unit, those kinds of things. The phonological loop is any sounds that you're playing with your computer, and your central executive is that processor that is creating the experience that's on your screen. Maybe a good example is watching a video, or editing a video, or maybe you have control over another good example is a video game where you're the central executive. You're controlling what's going on in the game based upon what you're seeing on the screen, what you're hearing from the game, and what is remembered about how you should go about playing that game. That might be a better example to go upon. Okay. All right, let me see. So I'm thinking it's 1:02, so let's go ahead. We're going to go ahead